So this video is for integrated 3. This is the chapter 12, D Day number 3, which we're calling pomegranate. So when we're dealing with number 1, 2, and 3, we are trying to solve for x, for all x, but we're going to be trying to get it to be like sine x equals or cosine x equals. Now on this situation, what I am going to try to do is I'm going to try to get my sine factored out, and I'm going to be left with 2 cosine x minus root 3 is equal to 0. So we have just factored this. So now either this is going to be 0, which would mean sine x is equal to 0, or this is going to be 0, which means that 2 cosine x would equal a root 3, which means that cosine x would equal a root 3 halves. So we want to figure out where that is. So when I'm doing this, if I'm thinking about the sine, where's my sine? 0. My sine is 0 here and here. So that is going to be at 0 and pi. Now for my cosine, where is my cosine? A root 3 halves. Well, for that, where's my cosine positive? That's going to be in quadrants 1 and 4. Okay, so that's where I'm going to be. And so when I'm thinking about my cosine, cosine is x, sine is y, and I want my cosine to be a root 3, which means, I'm sorry, a root 3 halves. That's my, what I consider long. So I am going to go long and then short. So I'm going to be right here at pi 6, which means I'm also down here at another pi 6, which is going to be 11 pi 6. Now, when I am going to give my final answer, since these are asking for all, I am really trying to see if I could write it in a simplified form. So I'm looking from here to here to see if the distance from here to here is the same as the distance from here to here, which it is, but the distance from here to here is not going to be the same. So it's not going to be easy for me to get from pi 6 to pi, then to 11 pi 6, and then back to the same location as my pi 6. So since those are not all the same distances from each other, I am going to have 3 answers. One of them is going to be pi 6 plus or minus 2 pi n, which is going to get me to here going forwards and backwards around the unit circle. I'm also going to have x is equal to 11 pi 6 plus or minus 2 pi n, and that's to get me back and forth to this spot. And then I am going to have my 0 and my pi. Now my 0 and my pi, I can go from 0 and add and subtract pi and go back and forth. So those ones I can write in a simplified form. And those are going to be my answers. On number 2, for this one, pay attention to, they want it from 0 to 2 pi only, but not including 2 pi. Okay, so we don't have to give, if 0 is the answer, we don't have to give 2 pi also as an answer. Now, for this, I want to get my sine squared by itself. So I'm going to add 1. I am going to divide by 2. And remember, when you take the square root, you always get a positive and a negative. So I'm going to have a plus minus. And then when I take the square root of 1, I get 1. And then when I take the square root of 2, I get root 2. We usually don't see it in this form because we rationalize this. We multiply top and bottom by root 2. And when we do that, our final answer for this, our final answer for this is going to be plus or minus root 2 halves. So I want to know where my sign is a positive or negative root 2 halves. Now my root 2 halves are going to be at my pi fourths. So I am going to have an answer here, pi fourths. I am going to have an answer here, 3 pi fourths. I am going to have an answer here, 5 pi fourths. And I'm going to have an answer here, which is 7 pi fourths. Now, in this case, since they want for a particular interval, we would list all 4 of these as our answers. On number 3, this is one that I want to factor. So if you want to think of this as, let's say, 2w squared plus 3w plus 1 equals 0, you can think about it this way. So this would be like a 2w and a w equals 0. Trying to multiply and get a 1. So this has to be a 1. That has to be a 1. So that means that this would be 2w is equal to 1. W would be 1. Actually a negative 1. Okay, this would be 2w would equal a negative 1, which means w equals a negative 1/2. This one's going to be w equals a negative 1. Now remember, these weren't w's. It really was a sine x that we were dealing with. So I want to figure out where sine x is equal to a negative 1/2. And I want to think about where sine x is equal to a negative 1. So where is my sign negative? Because in both of these cases, my sign is negative. So my sign is going to be negative down here in quadrants 3 and 4. That's where my sign is negative. If I'm focusing on this, where my sign is a negative 1/2, sine is y, 1/2 is short. So I want to go long, short, right to here. So that is going to be a pi 6. That is going to be 7 pi 6. Now, if that's an answer, then this is also an answer at 11 pi 6. Now, if I'm trying to figure out where my sign is a negative 1, again, my sign is y. So my y is a negative 1 down here at 3 pi halves. Now I'm trying to see, this one is a for all. So I'm trying to see if I can add something to get from one to the other and back and forth. This right here, all the way to here, is a much longer distance. So that's not going to be the same distance as here to here or here to here. So I am not going to be able to write them in terms of one of them. So my final answer is going to be, x is going to be 7 pi 6 plus or minus 2 pi n. X is going to be 3 pi halves plus or minus 2 pi n. And so if I just move this. And my last answer is going to be 11 pi 6 plus or minus 2 pi n. So those are my 3 answers. On number 4, we're being asked to verify. So we're trying to prove that the left side is equal to a sine squared x. So the first thing I am going to do is, I know that we have a an equation for sine squared x. Let me just highlight this. Sorry, sine squared x minus 1. So if I get my formulas out, the formula that I am looking at is this one here. I know that secant squared x is equal to tangent squared x plus 1. That's the one I'm going to be thinking of. So again, we have one, whoops. I'm just going to jot this down. 1 plus tangent squared x is equal to secant squared x. So what I am going to do is, if I was to rewrite that, tangent squared x is going to equal secant squared x minus 1. So I am going to, and on the top, where I had secant squared x, I can write that as a tangent squared x. So I can write tangent squared x there. And then this is still secant squared x. And now what I'm going to do is I'm going to write my tangent squared x and secant squared x in terms of sines and cosines. So the fact that I'm going to be using, okay, I'm going to be using, I'm just going to jot that here, that tangent of x is equal to sine over cosine. And the fact that secant is equal to 1 over cosine. So now I'm going to put sine x over cosine x over 1 over cosine x. And again, I'm trying to prove that that's equal to sine squared x. Now, what I can do is, when I am dividing by a fraction, I can end up multiplying by the reciprocal. So I'm going to have sine x cosine x times the reciprocal of cosine, and I apologize, these are squareds. These are squares because it was a tangent squared. So those are all squares. So this is a sine squared. This is a cosine squared. Okay. And so I'm going to be multiplying by cosine squared over 1. What's going to end up happening here is this cosine squared and this cosine squared are going to cancel out. And so I ended up with sine squared x. And remember, I was trying to get sine squared x. That's what the other side was. So we have just verified it. On number 5, first off, the formula for sine of 2a is equal to 2 sine a cosine a. And we're going to be in quadrant 3. So in quadrant 3, we're going to have our right triangle. This is our angle A. My sine of A is a -3/7. I'm going to do Pythagorean. So I have -3 squared plus x squared equals 7 squared. So 9 plus x squared equals 49. So when I subtract 9, I get x squared is equal to 40. When I take the square root of 40, that's really a 4 times 10. So I can really rewrite it as a 2 root 10. So this is going to be a 2 root 10, and it's going to be a negative because that's a negative x. So now when they want me to find sine of 2a, I am going to take 2 times my sine, which is a -3/7, times my cosine, which is a -2 root 10 over 7. And when I multiply that out, this 2 is really a 2 over 1. So I have a 2 times a -3, which is a -6, times a -2, which is a +12, root 10 over 49. And that's our answer. For number 6, we are asked to write this as in terms of a single angle. So when we have a situation where we have cosine of an angle times cosine of an angle, and then sine of an angle times sine of an angle. That is going to be one of our cosine. Now, sums or differences. Since this is a plus, this is actually going to be a difference. So the formula is cosine of, let's say, A minus B is equal to cosine of A, cosine of B, plus sine of A, sine of B. So my A and B are going to be this 5 pi eighths and my 3 pi eighths. So this is going to be cosine of 5 pi eighths minus 3 pi eighths, which actually ends up being cosine of 2 pi eighths. So that's really going to be cosine of pi fourths. Now, they asked us just to write it in terms of a single angle. We really could give the answer to that if we wanted to. The cosine at pi fourths is a root 2 halves. But again, they asked for it as a single equation. On number 7, this is our rational expressions. We need to get a common denominator. So I am going to take 9 over x minus 2. And for that, I need to multiply top and bottom by x plus 1 to help get a common denominator. Minus, and then the x plus 2 over x plus 1, I need to multiply that by an x minus 2 to get a common denominator. So now what I'm going to end up getting is a 9x plus 9 minus, and when I multiply out x plus 2 times x minus 2, remember that is a difference of 2 squares. Now there's a minus in front, so I'm going to put a parenthesis. So when I do x plus 2 times x minus 2, that's x squared minus 4. It's nice if you know how to do that fast, otherwise do a box. Over x plus 1 times x minus 2. So now let me just take away my parentheses, and remember I'm going to have to distribute that. So I am going to get a negative x squared. I am going to get a plus 9x. I am going to get a plus 9 and a plus 4. So that plus 9 and plus 4 are really going to become a plus 13 all over the quantity x plus 1 times x minus 2. And you could try to factor the top, but with that 13, it's not going to be factorable. So it's not going to cancel anything on the bottom. So that's our answer. On number 8, okay, we want to find the fourth term. So remember, for this, we take the power. It is the power minus the term, and then you're going to add 1. So I'm going to take 5 minus the term 4 plus 1. And so we're going to get 2 when I do that. So we are going to be doing 5, choose 2. 5 because 5 is the power. And then I am going to take my first term, which is 3x to the 7th, and I'm going to raise that to the power 2. And then I'm going to take the second term, which is negative 4, and raise it to what adds with 2 to get 5, which is 3. And I'm going to put this into my calculator. So let me put that in. So on the calculators, it's the alpha and window is what it makes it easy to get to. Number 8. And I'm going to type in 5, choose 2. And then my 3 here is going to be squared. So I have a 3 squared, which is 9, but 3 squared times. And then I have this negative 4 to the third power. So I'm going to take -4 to the third power, and I end up getting a negative 5,760 x to the 14th, because power to power you multiply. Let me just make my 14 look a little better. And that is your answer. On number 9, for this is the parabolas. This is the system. So I am going to have 3 equal a times 1 squared plus b times 1 plus c. Which is going to give me 3 equals a plus b plus c. My second point, 2 equals a times 2 squared plus b times 2 plus c, which is 2 is equal to 4a plus 2b plus c. And the third one is a -3 is equal to a times 3 squared plus b times 3 plus c. So that's going to be -3 is equal to 9a plus 3b plus c. So for this, what I'm going to do is I am going to, I could really eliminate any of them, but the nice thing every time with these problems is you're always going to have a plus c, and a plus c. So what that means is you can eliminate with that. So I'm going to take my purple equation and I'm going to multiply it by a -1. So I'm going to get 3 equal a plus b plus c. When I multiply that by a -1, I get a -3 equals a negative a minus b minus c. I'm going to use this once with the red equation, once with the orange equation. So let me take my red equation. So I get 2 is equal to 4a plus 2b plus c. I add these together. I get a -1 is equal to 3a plus b. That one, let's say, I'm just going to call this equation 4 as a reference. And I'm going to do the same process. Okay. So let me just rewrite my purple one again. So I have -3 is equal to -a minus b minus c. I'm going to do it with my orange one this time. So that's -3 is equal to 9a plus 3b plus c. I am going to add those equations together. And I am going to get a -6 is equal to 8a plus 2b. Now, what I can do at this point is everything's divisible by 2 in the second equation. I think I'm actually going to divide it by a -2, by a -2, by a -2. Because if I do that, I'm going to get 3 is equal to -4a minus b. So now what's going to happen is I can take this plus b and this minus b, and they're going to cancel out. Okay, so I'm going to take those two equations. -1 is equal to 3a plus b, and 3 is equal to -4a minus b. I'm going to add them up. I get 2 is equal to -a. So a is -2. I'm not done with that system. I still need to find the b. So I'm going to put it into the one that has a positive b. So I'm going to go -1 is equal to 3 times my a, which is -2 plus b. So I get a -1 is equal to a -6 plus b. I add 6 and I get my b is 5. Now I'm going to take both of these, my A and B, and I can do it into any of the ones at the top, but I think I'm going to do it into my original purple one before I times by a -1. So I'm going to do it to this one. So I'm going to have 3 is equal to -2 plus 5 plus C. So I get 3 is equal to 3 plus C.
So my C is 0. So my equation is going to be y equal negative 2x squared plus 5x. And that is our answer. So last problem, number 10. We have another system. Now, for this, we can do it different ways. I do notice that this equation here actually only has 2 variables. So I can keep that one if I want, and try to eliminate z in the other 2. So let's say I do that. So let's say I keep this one. So I've got my negative x plus 3y is equal to a negative 4. And so let's say I take equation 1. We'll call this one equation 2. And let's say this one is equation 3. And if I try to eliminate my z's, I'm going to take equation 1 and I'm going to multiply it by let's say a negative 5. So I can do that. Now this is one method. I could also easily deal with my x's and solve it doing that. I'm just showing us that if you do have one, you could just use the other 2 to get rid of the same variable. Up to you. So this is going to be a negative 5x plus 10y minus 15z is equal to a negative 45. I am going to take equation 3. I'm going to multiply that by, let's say, a positive 3. So 2x minus 5y plus 5z is equal to 17. Let me scooch this over. Just writing on the edge. Okay. Is equal to 17. So that's going to be a 6x minus 15y plus 15z is equal to, and that's going to give me a 51. Okay, so now I'm going to write that one underneath this one. So 16x minus 15y plus 15z equals 51. I'm going to add those together. I get x minus 5y. My z's cancel out, and I end up with a 6. I'm going to call this equation 4. So now my equation 2 and my equation 4 both have x's and y's. So if I take equation 2, okay, bring equation 2 down here, negative x plus 3y equal negative 4. My x's are actually going to eliminate. So when I do this, my x is going to cancel out. I get a negative 2y is equal to 2, which means y is equal to a negative 1. I'm not done with that system. I'm going to take that and plug it into, let's say, the number 4 equation. So x minus 5 times negative 1 equals 6. So x plus 5 equals 6. So I get x is equal to 1. And now I need to find my z. So the only way to find my z is to either use equation 1 or equation 3, because 2 doesn't have a z in it. So let's say I do it in equation 1. So if I put those into equation 1, I'm going to have 1 minus 2 times a negative 1 plus 3z is equal to 9. So I get 1 plus 2 plus 3z is equal to 9. So 3 plus 3z equals 9. So I am going to get 3z is equal to 6, which means my z is going to equal 2. So I had that, my y was a negative 1, my x was a 1, and now my z is a 2. So the point's going to be 1, comma, negative 1, comma, 2. And again, You didn't have to eliminate the way I did. You could have dealt with your X's first if you wanted. I probably wouldn't have chosen my Y's. But you can do it any of those ways. So that's the end of this video.